Good day everyone, welcome to the third dimension. In today's video, we're going to use Revit and we're going to add reinforcements to a structural beam. We're going to use IS 456 as our guideline, and then in our second video, we're even going to make a BBS for that beam, a bar bending schedule. So let's get started. Let's go to new and metric structural template. From here, let's go to level 1. And the first thing we'll do is we'll change the units. So we can even change the units by going to manage and then project units. And let's change the length to centimeters because it's easier to work with. So centimeters, fine. And you can even access units by pressing UN, right? UN, so that's the shortcut right there. So the first thing is let's go to structure and columns. Let's select 600 by 750 mm, or you can even select something else. And let's change this to height, and the limit for the height would be set to level 2. So let's place one column here and then another one, let's place it here. Okay, so here we go. Let's set the visibility to fine, and okay, this can be set to 1:50, which is the visibility scale. Let's set this to realistic. So let's firstly measure the distance between both of them, and we can even start from the wall faces. So let's measure the wall. Okay, that's 989 centimeters. Let's change this to 1000 centimeters. Okay, so then let's go to level 2. Let's zoom in a little bit. Let's go to realistic, and let's go to beams, structural beams. So or here let's choose 400 by 800 mm. Here you go. This is, make sure to select the exterior face to the other exterior face. So let's check this out in 3D and we can have a better idea of what we're doing. Here you go. Let's set the to fine and this to realistic. Okay, so this is the structure that we have made, and now let's get to the top view and let's add a section here which will help us to view the beam inside. So this is these dotted lines, as you can see, is the visibility limit, as I would like to call it. So let's set to this and let's double click it. If you double click this, okay, here you go. This is the beam that we're talking about. So I even have two other images which we're going to use for a reference. So one of the images is of this cranked bar. This is the crank bar which we're going to use inside our beam, and this is the distance, the crank length 0.42d. All of this is based on IS 456. Similarly, the second one is of this BBS of a usual beam. So these are the 4 different types of reinforcements which we in most of the cases have inside a beam. So this is our guideline regarding what types of reinforcements we're going to place, and in the second video we're going to make this inside Revit, but for this one we're going to use it as a guideline, and it's all based on IS code. So let's get back to Revit. This is the section that we have opened, and then I'll go to structure, and this is the reinforcement area that we're going to use now. So let's click rebar. Okay, and then on the right side, different shapes of rebars have popped up. So the first one, let's go for this one, according to the BBS, which I just showed you right now. Rebar shape M number 2. We're going to click this, and then right here, we're going to select current work plane, and then from this section, which is the placement orientation, we're going to select perpendicular to cover, and then we can place our rebars. But here, in fact, before placing the rebars, let's cancel this, and let's decide our cover. Cover is another important thing when it comes to structural members. Cover is the distance between the reinforcement and the exterior bar of the element. So let's click cover, which is within the reinforcement section. And this is pick elements. So let's pick this element. And in IS 456, it says that the minimum cover in table 16 for beams should be 25 mm. So we're going to select 25 mm from this cover settings. And if you don't have 25 mm right here, then we can select this, edit cover settings, and we can add our own to it. So let's add our own IS 456 beam cover, and let's set this to 25 mm. Let's press OK, and now let's select these elements, and let's set it to IS 456 beam 25 mm. Now, as you can see, let's click this button right here, which is for thin lines and thick lines. Yes, now we can see it better. Let's set this to fine. So now we have a cover of 25 mm. Even if you let that cursor stay there for a while, it's going to tell you IS 456 beam cover 25 mm. So this was the cover section. After doing this, now let's get back to our rebar. Let's click rebar. Okay, let's select this shape right here, which was the same one I showed you in the BBS, and a current work plane. In our placement orientations, we're going to select perpendicular, and we're going to place 4 rebars right here. Instead of placing the rebars manually, we can even, once we click a single rebar, and this rebar settings that we have right here. So instead of doing it manually, we can click this and we can set it to fixed number. And then let's choose 2. So now we have 2 rebars which are placed according to the fixed number that we have chosen. So this is better than doing it manually because it even automatically fills up that distance. And so let's delete this one. We can delete this, and we can do the same thing down here, which is to select one of them. Let's go to fixed number and 2. And every beam has a compression side and a tension side. So the upper side is compression. And we know that concrete is good in compression, but it's not strong enough in tension. So the upper bars are always, they're less in number and they're weaker in their thickness. So if this is 13 mm, it's 13 mm. If we go to edit here, 12.7, which is 13. And then for the bottom bars right here, we can choose 16, which is 15.9 mm bars. So that's 16. So here you go. Now let's go back to our 3D view. In our 3D view, we wouldn't be able to see it. So let's first change it to wireframe mode. These are the rebars that we have just placed. So let's select this, and then we have to go to graphics, edit, and let's click 4 of these boxes, which is view as solid in 3D view. And let's do the same for the bottom ones also. View visibility states, select all of them. And now if we go to realistic, here you go. So now we have that rusty look to it. and we can see it within our visibility view, in a realistic view. Okay, so now two steps are done. We set the cover, we placed the compression and the tension reinforcements. Now another important point is the development length. You know, the development length is also called as the anchorage length, and it basically it anchors or it attaches the rebars to the concrete. So lapping is the attachment, or you could say the connection between rebar to rebar, between steel to steel, while the development length or the anchorage length is from steel to the concrete. So the development length in this case is from where the column starts. So if we select the alignment dimension, from this area is where the development length should start. And if we click right here, that's 56. So that's 560 mm. And from this area to this area, that's 200 mm. For this exact state, let's go back to our units and let's set it to millimeters just for the time being. Okay, 560. So the formula for the development length given in IS 456 is there's a big formula for it in section 26, but the thumb rule which we usually use on site is 50D. So 50 multiplied by the diameter, and I believe it's always something close to 650 mm. So 560 plus 200 mm, I think we are on the safe side. But let's again change this length. I want to change this length and I want to bring it to here so that there's a better anchorage between both of them. I want to make it a better rebar. I want it to attach properly to the concrete. So we can do that by selecting the rebar and click edit type. Let's go to our hook lengths and then standard 90 degrees. This is the one that we have selected. So let's set this to 400 mm. And if you press OK, now as you can see, we have increased the anchorage length. So now the overall development length, we can change the units to, let's say 1 or 200. Okay, that's too much. 1:1. Okay. So now the overall development length is 560 plus 400. So now again, another step is cleared, which is the development length. As you can see, the bars in the compression side has a better anchorage than the ones in the tension side. So this is the concept of development length, which is given in IS 456. And we should even do the same for the bottom bars. So let's go to edit type and let's click on hook length, and it's 250 mm. So let's change it to 400 mm. Okay and okay. Here you go. So that's the development length, which starts when the column starts. Now this is another concept cleared. Okay, so let's move on. So now the cover is done, the bottom and the top compression bars are done, the development length is done. Now let's go back to level 2. Let's go to our section. Now it's time for the ties, which is the shear reinforcement. Or in fact, the ties are the ones which are placed in columns. In this case, it's the stirrups. So let's go back to structure, rebar. Let's select rebar, and from this rebar types, we have to go down and look for stirrups. Stirrups. So I think it's this one. Yes, this is a stirrup. But let's change this to parallel to work plane. Here you go. This is the stirrup I was talking about. So now it's current work plane, and in the placement parallel work plane. So let's just click it, and we have placed the stirrups. Now we're going to do the same for the visibility graphics as we have done before. View visibility graphics, and let's click 4 of these boxes. Now let's go back to our 3D view, and this is the stirrup that we have placed. So let's click this, and let's go back to our rebar set section. For the other ones, we set it to fixed number, but in this case, we're going to set it to maximum spacing. So the maximum spacing, and then the center to center distance is 100 mm. So now we have the stirrups. Here we go. Now, as you can see, the stirrups are also done. So as you can see, if the center to center distance is set to 100 mm, then there are a total of 101 stirrups that we have attached. That fills up the space. But in this case, another important concept of civil engineering comes in, which is the area close to the columns. The area close to the columns has the most amount of shear force, and as you move towards the center, the shear force decreases, but the moments at the center is the most. So stirrups are called shear reinforcement for a reason, because they're the ones who have to counter the shear force, which is most at the columns. So the stirrups close to the columns have less of center to center spacing, while the stirrups in the middle have more spacing of center to center. So we even have to change that. So this is another concept which we even have to do in our placing of bars. So let's do this. If we go to level 2, I hope I'm going to make my point clear within a few moments. And let's go to wireframe mode. Now we have to divide this distance to 3 parts. And we're going to do this by architectural. And model lines is the one that we're going to use. Usually we have 2 different types of lines. One is in annotate, we have the detailed line, and in architecture, we have the model line. There's a difference between both of them. That's going to be another video. I'm going to talk about that. For now, we're going to use model lines. And, first, let's go to our alignment. Let's click on our alignment and let's check what distance we have. If I remember, it was 1000. So 1000 centimeters or 10,000 cm. Let's click on UN and let's set the units back to centimeters. We had to change that. So now we have to divide this section into 3 equal parts. Let's go to architecture, model lines, and let's set 2 model lines randomly right here. Now let's delete this for the moment. Let's go to aligned dimension, and from the first model line, okay, let's start from here. From here to the first model line, and then to the second model line, and then till here. Okay, and now the best thing about Revit is just pressing this EQ that it's written over here. Let's change the scale to 1/200. If that's better, yes. So if you just press equal, so it's going to set the model lines, and the distance between all 3 of them is going to automatically set to equal distance. So now if you get my point, now if you just measure this, so it's 333. It means our 1000 distance is divided into 3 equal parts. So this is what I wanted to do. Now, as I previously said, that the distance between the stirrups, the center to center spacing, is going to be different. So now let's just click on our stirrups and let's bring this to our first model line. Okay. Same case as this one, same case. Let's okay. Now we have made one of the sections. So in this case, the shear force is the least. So for this, the center to center distance can be set to, let's set it to 250 mm. Yes, so it's only 15 number of stirrups have fitted in this area. Now let's go to the section that we placed. Let's go to level 2, or let's click on level 2. Okay, now let's place another section, and if that one is not showing up, so, and let's decrease the visibility range of that section. So now if we click it twice, this is the beam that we have. And then again, if you go to structure, rebars, if you choose the same rebar and you press it right here, and then similarly you change the visibility settings to click all view as solid. And if you go back to our 3D view, here you go. So this is the second set of stirrups. Now let's again go back to maximum spacing. And this is the stirrups which are close to the columns. So the center to center distance between them is going to be less. So for the other one, for the middle one, we set it to 250 mm. For this one, let's set it to 150 mm. So 68 number of stirrups. But this is going to change because, you know, we have to decrease the spread of it. You know, the distance through which it's spread has to be decreased. For better performance, so let's set it to coarse. Yes. I don't know why there's a lag. Okay, so now as you can see, here we go. So 24 number of stirrups. So do you get my point? This is the point that I wanted to explain. The center to center distance between the stirrups in the middle is going to be less because shear force in the middle is less. It's the least, in fact. And shear force towards the columns as you get closer to the columns is the most. So the center to center distance of the stirrups towards the columns is going to be more. Or here we have 150 mm, and right here we have 250 mm. According to IS code, we can even set it to 300 is, I believe, the maximum center to center spacing. So let's set it to 300. And now let's get back to level 2. Let's move this section to here. And you know, we can even delete this because we know that it's already set to equally spaced. The range of this is fine. Now let's click it twice. And now we are back to the same area. So let's go to rebar. Let's select the same and let's click again. Now we have placed rebar. We are going to again go to the view visibility states. We're going to select 4 of these boxes so that we can view it as solid in 3D view. Now you can see this is the other rebar, that the other stirrup. So let's go to maximum spacing. Okay, let's go to the south elevation. It's easier to change it from this side. Let's go back to our 3D view. In fact, let's get to the top view because so that we can see the model lines. So these are the equally placed model lines. And Okay. This is how it's something going to be on site. Even for this case, this one, let's get into this. So 23 in this case, which is 150 mm, close to the column. This is 300 mm, and this is again, let's set the center to center distance to 150 mm. Here we go. Yes, this is what I was talking about. So the model lines, we have used them quite good, and they're equally placed, and they're very handy. So now the cover is done, the beam is done, the compression and the tension reinforcement is done, the stirrups are done, and the stirrups towards the columns have a less center to center spacing, while the stirrups in the middle have more, because shear force towards the columns is the highest, and these are called shear reinforcement for a reason. So I hope you guys get my point. So moving on. Okay, so now the fourth type of reinforcement, the fourth type of rebar is these ones, the ones which you can see in number 3. So this is the last one that's left. We have done the other 3. This was the reference table that we initially talked about. So let's go back to Revit, and let's go to level 2. Let's go to this section, and now rebar, and let's search for the shape that we saw in our bar bending schedule, in our table that I showed you. This was it. M4, this is the one that we talked about. So let's click on this, and let's change this to parallel to cover. And as you can see, let's change its settings the same as we did for the other ones, so that we can see it in 3D view, and we can even change it. If we go to the 3D view, here we go. Now let's go to our south elevation, and let's extend this. Okay. This was the crank length which we saw right here. It's 0.42D, but now I don't want to get into too much detail because the video is already too long. So let's just roughly place it here, and let's set the fixed number. Let's go to 3D view so that we can see it properly. Okay, the fixed number is set to 3. Let's set it to 2. Okay, here you go. We are done. So these were the 4 different types of rebars which we are going to place. And I think our beam design is complete. If you go to the table, the reference table, we have placed the tension rebars, the compression rebars, and these are the middle ones, and these are the stirrups. They are called the side reinforcements in beam design. In IS 456, they're termed as the side reinforcements. So our beam reinforcement is complete. We have placed the compression bars, the tension bars. We have done the development length. We have given the cover, which is 25 mm, and we have placed these cranked bars, and we have placed the stirrups, And now I believe the final thing which is left is the visibility. We can improve the visibility a little bit. If we go to shaded, and then if we just select one of these bars and we right click, from here let's go to override graphics. Let's change this to solid, which is the pattern, and let's set it to red. Here you go. Now you can improve your visibility of the rebars by this. So we can do the same for the others. For example, if we click twice on the section and let's go to wireframe mode. Okay, let's go back to our 3D view. Okay, so we have given it a blue color, and now these crank bars are left. They're easy to select when in wireframe mode. So there you go, override graphics by element and solid fill. Again, let's give it a green color. Here it is. So this was your beam reinforcements, and in the next video we're going to make a bar bending schedule of this exact structure, and we're going to use this as our guide. So thank you for watching, and stay tuned. Thank you.